chapter 31 for your maths Igcse. The chapter topic is vector. Chapter 31 is vector, chapter 32 is transformation. So after vector, we look at transformation again, and then we look at chapter 34 and 35, which is statistics. Okay, so we've had our probability, so you can check our YouTube channel, Wisdom Academy, and you'll find all our videos. Now, without wasting time, without much ado, let's begin. Vectors. Okay, this at the beginning of physics, you'll be hearing scalar quantity, vector quantity. This comes up every now and then in physics. So we've talked about vector a lot. Okay, we've technically talked about vectors. So, but right now we are doing the applications of vector. Right now we'll be dealing with the applications of a vector. So vector quantities are quantity with the magnitude and direction. We've said that in physics, time without a number. However, in mathematics, the story is a little bit different. What we're going to be, it's not like different, but we'll be showing the application. Okay, the application of vector. Vectors are described using what we call translation. In transformation, there are four methods of doing transformations. There are four methods of doing transformation. One of it is reflection, one of it is translation, another one is rotation, and another one is enlargement. So we'll be studying translation in the next chapter again. We'll study reflection, we'll study all of them, other transformation. Now let's take a look at translation as it is used in vector. Let's take a look at translation as it is used in vector. Translations just simply mean a sliding movement. When you can either go vertical, okay, we call this movement the vertical distance, which is called the y-axis, and we call horizontal distance the x-axis. The horizontal movement, we call it the x-axis, okay, in coordinate geometry. Now, but there are other movements which is not vertical, is not horizontal. It could be a combination of both. For example, if you're sliding this way, you are including both horizontal and vertical. So you're moving in the positive x direction. You are going up, which means you're also moving in the y direction. So these are called sliding. You're sliding like a gradient, like a slope. So it's a sliding movement. Any sliding, whether the movement is this that is like this in a negative gradient manner or is in the positive manner, it's a sliding movement. Okay, so this way, if you have your graph, if you have a complete graph like this way is your positive x, this way is your negative x axis. Okay, if the top here is your positive y axis, the bottom here is your negative y axis. Okay, so this is a geometry. This is your plane geometry. Okay, now any movement, if you move like this, is a sliding movement. If you move like this, it's a sliding movement. Okay, it's a sliding movement. So if you move, however you move, if you move like this, it's a sliding movement. As long as you're not moving vertical, neither are you moving in horizontal manner, then it's a sliding movement. Is that okay? Okay, so we say translation is a sliding movement, and it is only described by what we call the column vector. A column vector has the x axis or x value of the coordinate and the y value. So this is what we call a column vector, meaning one column. Why we call it a column vector? Because it has only one column. If it has two columns, it becomes a matrix. We're talking about matrix. If you have x here, you have another one, maybe x1, y1, x2, y2, it becomes a matrix. A column vector is used to describe a translation, and translation is a sliding movement, and that's what vector is all about. Vector is about movement. Either you're moving in horizontal manner, or you're moving in vertical manner, or you're moving in both x and y axis direction. Is that okay? So that's what translation is. Translation is simply a sliding movement in the plane geometry, in the x and y direction of the plane geometry. Is that okay? Now let's take a look at a basic example. It says describe the translation from A to B in the diagram in terms of column vector, the movement from A to B. Now let's assume one box, every single box represents one digit, okay? So if I move from here to here, I call it 1. If I move 2 boxes, 2. If I move 3 boxes, like this one, 3 boxes, it's 3. Now, if the movement is upward, if the movement is vertically upward, we call it upward movement. We use plus for the value. If it's upward movement, we say positive. We say it's positive. Okay? We say it's a positive y value. We say positive y value. Okay? Then if it's downward movement, we say negative y value. So when our vector or when our object is moving downward, we say negative y value. Now, if we have horizontal movement in the x-axis in this way, we say positive x-axis, okay, positive x. And if we are moving this way, we say the negative x-axis. Okay, we say the negative x-axis. Okay, so that's established. Now let's take a look at this. It says we should write the column vector. Now to write the column vector, it means we have to tell the x value from A to B and the y value from A to B. We should be able to tell the x, how many boxes we have moved in the x direction. So if you take a look at A to B, it's a sliding movement. So only one box was covered in the x-axis, meaning the distance covered only one box horizontally. Since it covered one box horizontally, we call it what? 1. And it's moving upward, so we use positive 1. Okay? We don't say over. It's we don't say over. It's not a fraction. Okay? Then in the y-axis, you can see it has climbed up how many boxes? 1, 2, 3 boxes, and it's going up. Since it's going up, we're going to say positive 3. So the column vector from A to B is 1, 3 like this. The column vector is 1, 3. That's what we have here, the column vector. So you go to write the vector. You go to write it. You say AB, vector AB. You put the vector on top to show the direction. Because vector quantity must have not only the value, which is the magnitude, must also have the direction. Okay, which shows is a vector. So AB, the movement in the x plane and y plane, shows 1, 1, 3. Is that okay? This is how we represent it. Now, what it means is that the vector has moved only 1 unit in the x direction, which is 1 box. Has moved only 1 unit in the x direction and 3 units in the y direction. Now, let's say another one. Say describe vector BC, CD, and DA in terms of column vector. So we're going to describe BC. Now let's take a look at vector BC. Let's change quickly. Let's take a look at vector BC and see what we're going to have. Okay, if we have vector BC, we always put this on top, an arrow on top to show it's a vector quantity. Vector BC will, now we go to this place. You see, it moves horizontally, it moves how many boxes? It moves 2 boxes. So BC moves 2 boxes, 1, 2. So I write 2 for the x value, the x-axis value, we write 2. Then the y value, it didn't move, it didn't go up, it didn't go down, so it's 0. It did go up on the y-axis, it did go down, so it's 0. So our BC, vector BC, is 2, 0. Now what of vector CD? Vector CD. Let's take a look at vector CD. And what we do is just to study from the graph, from what is given to us. Vector CD, it means that it moves downward vertically. It didn't move any horizontal distance. So horizontal distance is 0. There's no horizontal distance. Horizontal distance is 0. So I'm going to write 0 for x-axis, for the x unit. And then the y unit is 2. But the 2 is going down. So if it's going down, it means it's going to be negative 2. If it's going up, it's going to be positive 2. I already showed that. If it's going up, it's positive y-axis. If it's going down, it's negative y-axis. So since it's going down, we're going to write negative 2. by how many boxes it went down, that determines the value. If it went down three boxes, you say -3. So you can see this vector. Now the last one, vector AD. Vector AD is simply now we look, the x-axis, it has covered some distance in the x-axis, but it's going towards the left. So when you are going to the left, you will become negative. This leftward. If you're going leftward in the x-axis, you're going to be negative. If you are going rightward, you're going to be positive. If you are going rightward, you're going to be positive, right? If you are going upward in the y-axis, you're going to be positive. If you are going downward, you're going to be negative in the y-axis. Okay, for x-axis is left and right, for y-axis is up and down. Okay. Now, so if you take a look at DA, vector DA, this one is not actually AD because look at the arrow. It's going from D to A, so we don't call it AD. AD means the opposite. Okay, so vector DA here, let's permit us to write the property vector DA. Okay, so here we have DA. So vector DA, we look at how many boxes does it cover in the horizontal sense, in the horizontal orientation. How many boxes? 1, 2, 3. Technically, there are 3 boxes on the horizontal, but it's going left. So you say -3. So we're going to say -3 here. -3 here. And then how many boxes did it cover in the y-axis? Y-axis is also going down because it's going like this. So, but it covers only 1 box. Vertical box it covers only 1, the vertical box. Because it starts from the top of this to the bottom here. And it's -1. So we put -1 for the y. Put -1 for the y. So this is how to show it. And if they give you this column vector, you should also be able to draw it like this and get this one. So you should also be able to draw it. Either they give you this, you give them the column vector, or they give you the column vector, you draw the vector in the geometrical space. Is that okay? So we're done with this first part. Now let's move. Let's go to the next one, which has something to do with. We say translation can also be named by a single letter. So instead of writing DA, you can just call it vector A, small letter. You bold it, okay? Or small letter B, small letter C. So you can use small letter to represent vectors. Is that okay? You can do that. Okay. So that's that for that. And let's talk about define. Here is a translation can also be represented by single letter. The direction of the arrow indicates the direction of the translation. Yeah, we already talked about that. The direction of the arrow shows you the direction of the translation. For example, this one is going rightward. If you look at this vector A, it's going rightward. Since it's going rightward, the x-axis will be, it covers 2 boxes. It will be +2, which is +2. But it's also going upward. And in the upward manner, it covers how many boxes also. So which means, technically, we are talking about this in the horizontal sense. We are saying that it covers these 2 boxes up to this place. And in the vertical sense, it covers also 2 boxes. So this vector, and they are both right and up. So this will be +2. Vector A is 2 and 2. Vector A, like you see here, is 2 and 2. Vector A is these 2 and these 2, because it covers 2 boxes to the right, which is +2, and 2 boxes up, which is +2. So that's how we got this vector A as this one. Now let's take a look at vector B. You see this one is going to the left, and it covers 2 boxes. So the x-axis will be -2. The x-axis will be -2. But you see, in the y-axis, it's positive because it's going upward. But it only is only within 1 box. It's only within 1 box. Since it's only within 1 box, it's 1, +1. That's how we got this one. Okay? So that's that for this. Now, another thing we can do, vectors can be multiplied, magnified, and shown. You can be given some vector like this, they ask you to draw it. So this one is good. The x-axis will cover 2 boxes. Anywhere you start from, if I start from here, the width of the vector will be 2 because x is 2. So I'm going to draw a line up, but within 2 boxes. From the beginning to the top, it has to be within 2 boxes on the x-axis. And to the top, I have to cover 5 boxes up. So let's say I start from here. We did 2 boxes. How many boxes up? 1, 2, 3, 4, 5. Meaning I'm going to end here. So I will start from here. I will start from, let's say, just now I think I was showing. So let's say I start from here. How many boxes? 1, 2, 3, 4, 5. So I'll start from here. We did 2 boxes. I have to draw a straight line that will end in the second box in the 5th vertical upward, this place to this place. Okay, your line must be straight. You use a ruler in your case. Use a ruler, then you show with an arrow that it is going up, that it is going up. You show with an arrow that it is going up. So this is for this vector. Okay, 2 and 5, positive. Then negative 3, meaning on the x-axis you're going to cover 3 boxes and you go down only 2. Okay, so you get this vector. Okay, now let's move on. So here, for what we've just described, we have a lot of things to do. We have a lot. If they ask you to find the negative, they give you this one, it's a positive. Find the negative, is just to bring it down. Find the negative of this is for this to go up. Is that okay? It's just the opposite of what you've just done. The opposite of what you've just done. Okay, now here you pause the video and solve all of this. They give you some this thing they ask you to tell. Say question 1 and 2, describe each translation using a column vector. You describe each one using a column vector. So you pause, you do. Now if you see this one is only covering 2 boxes. So and it's going rightward. Since it's going rightward, I have 2 for x. And how many boxes up? 1, 2, 3, 4, 4. So it's 2, 4. So if I want to do this one, I will say 2, 4 for vector AB, 2, 4. And then I close it like this. Vector AB is 2, 4. Is that okay? So for AB, vector AB. BC is covering 3 boxes in the horizontal axis, which is positive 3. And is only within 1 box in y-axis. So it's going to be 3, 1. Y-axis is also going up, so it's going to be 3, 1. This one is going to be 3, 1. Okay? So you should be able to give all the color vector for all of them. This one is going down. Okay? You count how many balls which is going down. 1, 2, 3, 4. So it's minus 4 for y. And there, how many balls does it cover for x-axis? It's covering 2 boxes. And it's going leftward. So this one is minus 2, and minus 4, because it's also going down. Minus 2 and minus 4 for this one. Okay, I think this one we should have been writing them close to their this is 2, 4. This vector is 2, 4. AB is 2, 4. This one is 3, 1. This vector is 3, 1. BC is 3, 1. Okay, this vector is going rightward, so, and it covers how many boxes? 1, 2, 3, because cover from here to here, 3 boxes. So, and it's going this way. So x is positive, so I write 3, positive 3, and it's going down, so the y will be minus. And how many boxes does it cover downwards? 2. So I write minus 2. So this one is vector is 3, negative 2. So we should know, if we give you something like this, how to label it. Is that okay? So that's that for that. And pause the video and do a lot of work here. Here is going leftward, so it's minus 3 on the horizontal axis and 0 on y-axis, because it's not going up, it's not going down. So minus 3 and 0, this for this one. Okay? So that's it. Pause it and do all of this for a problem. Now let's go to addition and subtractions of vector. Let's quickly go to addition and subtraction of vector. You know, vectors, we can add them. They give you vector A plus vector B. We can add them diagrammatically, and we can add them numerically. Okay, vectors can be added together. Okay, now the translation is always represented by letters, maybe A and B. Now if you have vector A defined, they've given us vector A. Let's take a look at it. The vector is 2, 5. They did with vector A, and this is vector B. This one is B, and this one is A. Okay, so we have to add this one together. Whatever we get, we determine our third vector. You can call it vector C, or you call it vector A plus B. Okay, A plus B. Now vector A is 2. 2 plus minus 3, you get negative 1. Then 5 plus minus 2, you get mini 5 minus 2, you get 3. So we get this vector. First and foremost, the first thing we do, we start from wherever we want to start, and we draw the translation of this vector. The end of it, that's where we begin this one. Okay? The end of it, that's where we begin this second vector. So now technically, let's take a look at what we have. We draw vector 2, 5. 2 for the horizontal vector A. Look at it. 2 for the horizontal axis. Positive 2 because meaning it must be sliding. It must be sliding to the right. So and must cover 2 boxes and upward and 5 upward. So I count it. Let's say I start from here. We start from here. We count 5 upward. 1, 2, 3, 4, 5. So meaning I'm going to cover horizontally. I'm going to cover 2, and vertically we're going to cover 5. Horizontally we cover 2 boxes because it's given here 2, and vertically we cover 5 boxes. So meaning I will start from here and slide till I get here, till we get here, right? We slide till we get to where we are going. So this is your vector 2, 5, which is vector A. Column vector 2, 5, which represents vector A. Once that is drawn, then the next thing we draw minus 3. So meaning this one, the x, where you stop, that's where you continue from. Where we stop, that's where we go to continue from. Right? We started from here. We cover 2 boxes for the horizontal, this value 2. And but we move within that 2 boxes, we move 5 boxes upward. Within the 2 boxes, we move 5 boxes upward. So it lands us here. Then the next one is negative 3. Where we stop, we continue vector B. That's for vector A. Where we stop, we continue vector B. Vector B is negative 3 for x and negative 2 for y. Meaning, since it's negative 2, meaning it's going to go down. It's going to go down. Okay, because y is negative. X is negative, meaning it's going to go leftward. So we are not going to continue this way or this way. Since it's negative 3, we're going to move 3 boxes all together horizontally and 2 boxes downward. So we start from here, we mark 2 boxes, 3 boxes horizontally and 2 boxes downward. We arrive here. We put the arrow showing that it's coming from here to here. Then you see we now get vector what? Negative 1, the answer, the solution. Because this is the first 2, the question, then the A plus B, you get minus 1. Minus 1 means the horizontal vector will be started from where you started originally. Okay, the horizontal vector will be started from where we started originally. So which means minus 1, you start from here for the horizontal vector. Remember, you draw vector A, you draw vector B. This space was remaining. Now you got this vector minus 1 and 3. So 3 means I'll go up. 3 for y-axis means I have to go up. So not here. You cannot go from here. You cannot go up from here. You have to start from the resultant solution from the origin where you started from. So 3 means you go up. 1 means within 1 box, you have to move. Your 3 point that you're going to draw upward has to be within 1 box, but to the left side. So you see you draw from here to here and you show with the arrow. So that's how we solve this addition of vector. Now we're going to go to the subtraction. We're going to go to the subtraction of vector. Okay? We're going to go to the subtractions of vector. The same number we're going to use. Let's say the same vector A is 2, 5. The same vector A. The value of same vector A is 2, 5. Is 2, 5. So we draw that 2, 5 for vector A. We draw that 2, 5 for vector A. So that's what we have here. 2, we did 2 boxes. See this line? And 5 upward. 5 upward. We have 5 upward. Okay, just a moment, okay. We have 5 upward, you can see. So this one is covering these 5 boxes upward. If you count the box, starting from here, 1, 2, 3, 4, 5. There are 5 upward. So that's this positive 5. This 2 is the x-axis, meaning you must cover a space of 2 boxes as you are going up. Starting from here, you're only going to cover 2 boxes on the x-axis till you get to the top. Okay? Meaning 5 vertical like this, and 2 boxes like this. So your line must start from here and ends here. So that's your vector 2, 5. Now, the next thing we do it normal. We subtract the vector. So what do you have if you say 2 minus minus? You know, this minus. 2 minus minus will be plus. So 2 minus minus 3, you get positive 5. And this one you get 5 minus minus 2, it becomes plus, right? 5, it becomes 5 plus 2, which gives you 7. So now you have 7. What are we going to do? We're going to draw, this is subtraction, right? This is subtraction. So we're going to count 5. First of all, let's draw the vector B. The vector B. You know, this is vector A, and this is vector B. Now vector B, if you look at vector B, is a negative because it's minus B. Look at it, minus B. It's not like plus B. Okay, it's not like plus B. So it's similar by saying A minus B same as A plus minus B, right? So since it's minus B, we can do the negative values. The negative values will make this one to be what? Positive 3. Because minus times minus 3. Minus times minus 3. Minus times minus 3, you get positive 3. And minus times minus 2, you get positive 2. So if you're about to draw this one, the negative B, if you're about to do negative B, because this is B, this itself, in itself is B. If you want to do negative B, you know you started from here, you stop. This one is now positive 3. So you'll be wondering, why is it going this way? Because minus times minus 3 is positive 3. So here we stop, we continue from there. We're going to have a positive 3 on the horizontal axis, covering 3 boxes. Look at it, it's going to cover 3 boxes on the horizontal axis, and it's going to cover positive 2 on the vertical axis, meaning it will go up. So the reason is that because we are drawing negative B, we are not drawing B. Because we say vector A minus B, we are doing for minus B. We've drawn vector A, which is this first one. Now we are drawing for minus B. We are considering the minus with whatever value is here. So minus times minus 3, we get positive 3. So here, technically, we are doing positive 3. That's why the vector is going to the right. It's going to the right it's sliding right on the x-axis. And it's sliding upward on the y-axis because minus 2 times minus, it gives you positive 2. So it has to slide up. So why we put minus B here? Because we are not drawing vector B. Vector B is this value. If you are drawing vector B, this one would have slided to this way, left side and downward. We would have been going this way. But we are doing minus B. That's why we got this. So after we reached here, the next is to do from the origin, the solution, A minus B. Now A minus B, you can see is 5 on the y-axis. You can see it's 5 on y-axis, 5 on x-axis, and 7 on y-axis. So I'm going to count 5 boxes. 1, 2, 3, 4, 5. So it will stop here. And 7 on the positive 7 on the y-axis. So I go up. 1, 2, 3, 4, 5, 6, 7. So I'll start from the origin, the beginning. I'll draw an arrow to join to the end of negative B vector we did. And we'll put an arrow. So this is for minus, negative. And the first one we did was for positive. How to add the vector in geometry. Okay, so here are some questions for you to practice. They've given you vector A value, they've given you vector B value, they've given you vector C value, they've given you vector D value. Now play with this. Do A plus B and get the values and draw the vectors. Do B plus A and so on and so forth as you have it here. Now let's go to multiplying a vector by a scalar. This is easy. If they give you vector A is 1, 2, if they say find vector 2A, what you simply do, if they say find vector 2A, it means that you should double A. Multiply whatever A is by 2. So since here was 1 box, if you multiply by 2, the horizontal value will now be 2 boxes. And the vertical value that was 2 boxes will now be, see, the horizontal value was 1 box. And the vertical value was 2 boxes. Now, if you multiply by 2, scalar multiplication, the horizontal will now be 2 times 1, because here is 1. 2 times 1. You have to multiply this one 2 times 1. That's what we have here. You multiply by 2. This 2 is the scalar value. So 2 times whatever A was vector 1, 2. 2 times 1, you get 2. 2 times 2, you get 4. So I will have 2 boxes on the x-axis, and I will have 4 boxes on the y-axis. We have 4 boxes on the y-axis, and we show with the arrow, starting from the beginning here to the end here, we draw an arrow to show that. Is that okay? So that is scalar multiplication of vector. That's simply for scalar multiplication of vector. Simply for scalar multiplication of vector. Okay, now let's move on. Let's take a look at work example. If vector A is 2, -4, express vector B, C, D, E in terms of A. Okay, B, C. So this is vector A. Look at vector A. You can see that it's sliding down. So, and rightward. So this one is positive. Positive 2, cover two values on the x-axis and -4 on the y-axis. Now vector B will be what? Vector B is going up, which is the opposite, and is going leftward. These 2 will now be minus. The x value will be minus, the y value will be positive. Okay, so we call this vector minus A. We call this vector minus A. We call it what? Minus A. Why do we call it minus A? Because it's going opposite to the direction of A, and it's same scalar value. Same value, but it's going opposite. Is that okay? This one, they are going the same direction, but it's half of A. So we call this one 1/2A. Because it's half of A. This one is half of vector A. Why is it half? Because this one horizontally, it covers 2 values. Horizontally, it covers 2 values, and vertically, it covers about 4 values. This one horizontally covers only 1 value, vertically covers only 2 values. So it's half. Is that okay? This one is half. Now we take a look at this one. This one, how many does it cover? Horizontally, it covers 3. Vertically, it covers how many? No, horizontally, yes. Horizontally, is going leftward. So this is -3, right? We read this one. -3, we go up 1, 2, 3, 4, 5, 6. So this one we have -3 and 6. -3 and 6. So which means it's like 3/2 of A. It's like 3/2 of A. That's 1.5, 1.5 of A. 3/2 of A. Of minus A, because it's going opposite A. Okay, this one is going the same direction of A. This is like 2A, because this one cover how many boxes? 1 horizontally, 2, 3, 4. 4 boxes, which is 2. 4 means double of 2. Then the vertical, I think it's 8. We can count 1, 2, 3, 4, 5, 6, 7, 8. So this is 2A, and it's going the same direction as A. So if you want to describe this one, C, vector C is equivalent to 2A. Equivalent to vector 2A. It's equivalent to vector 2A. This one is equivalent to 1.5 or 3 over 2. You can say that minus 1.5 a. This vector is minus 1.5. Why do I use minus? Because it's not going to the direction of a. It's going to the opposite direction of a. This one is minus a. This vector is equal to minus a. If you are defining all of them in terms of a, this one is minus a. They are same in magnitude but opposite direction. This and this are same in magnitude but opposite direction. This one is half of a. It's going the same direction but it's half. So you can say 1 over 2a. You can say this one is 1 over 2a. This vector d is 1 over 2a. Okay, so you pause and do a lot of all of these, and let's move on to the next one, the magnitude of a vector. Let's move to the magnitude of a vector. Now, the magnitude is simply means size. Magnitude simply means what? The size of a vector. Okay? And it's like the length. It's like the Pythagoras theory. When you're looking for the hypotenuse, the longest side. You know, where you used to say a squared plus b squared equals to c squared, right? And you make bc the subject. So you find square root of this minus this, and so on and so forth. Now, they've given us a vector. Let's take a look at this vector that is given to us. We have vector a to be 3, 4, and we have vector bc. You know, you can use this small letter, or you use, when you're using a capital letter, you must put arrow on top, bc, meaning from b to c is minus 6 and 8. Represent both of the vector, represent both of the above vector diagrammatically. So first of all, show vector. This one, let's say you are starting from here. It means you have to move 3 times for the horizontal direction. I have to move 3 times because x-axis is 3. 1, 2, 3 must end there, and 4 upward because it's positive. 1, 2, 3, 4. So meaning I will start to draw and slide from here to here. So that's this for this vector 3 and 4. Now for vector BC, you have minus 6, meaning I'm going to go leftward 6 times, 6 boxes. So since you already know you're going to go leftward 6 boxes, you have to come this way to start, because you're going to go leftward, and 8 upward. So you go to the bottom side because you're going to draw 8 upward, slide it to the negative side. So if we start from here, you're going to count 6 boxes to the left. Let's count 6 boxes to the left. 1, 2, 3, 4, 5, 6. See, 6 boxes to the left. And we're going to count how many boxes to the right. We're going to count how many boxes to the top. 8 boxes. We're going to count 8 boxes. Okay, it's lagging now for a minute. We're going to count 8. 1, 2, 3, 4, 5, 6, 7, 8. So where it meets, meaning you start from the bottom of here and slide till you get to the top here, and you put an arrow to show that movement. So that's the first thing they want us to do. It's connecting, but we can keep explaining, okay, without touching the. Now the next question is to calculate the magnitude of A. Once you see, okay, I think this one has been restored. Okay, now we say count 6 to the left. 1, 2, 3, 4, 5, 6, right? And count 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Then you start from here and slide to the top here. You show an arrow that you started from here. So this is vector BC. You show BC in the diagram. Now the next question says we should find the magnitude of vector A. That's the next question. That we should find the magnitude. To find magnitude, you know this magnitude is simply defined like this. Magnitude, which is this sign. Magnitude we put like this. See. We call it modulus also. Magnitude, once we put like this, is equal to, what it means is equal to the x squared plus y squared, s squared plus y squared. S squared plus y squared. Is that okay? Then all square root. We're finding the magnitude. This is how to find the magnitude. S squared, what's s? X is 3. And y is what? 4. So for this question, you say 3 square plus 4 square, all square root. Like you're doing Pythagoras theory, right? Remember, the x as a square plus y as a square, there all square root. So 3 square is 9, 4 square is 16, 16 plus 9 we get 25. Then you find the square root of 25. Don't forget to find square root. So you find square root of 25, you get 5. Okay, you get 5. That's it. That's the magnitude of vector A. And magnitude means if they want you to calculate magnitude, they will put this thing. In the exam, they may not use the name magnitude. They may just say find. They will just say find. They will write like this. Find this. They do like this. They just do it like this. Find this. Once they do like this, they ask you to calculate the magnitude of the vector. They ask you for the magnitude of the vector. Now, also to calculate the magnitude of vector BC, is same thing. Minus c squared, because this is x. Minus c squared plus 8 squared. Minus 6, if you square any negative number, it will become positive. Minus c squared will give you 36. 36 plus 8 squared is 64. Plus 64, you get 100. And if you find the square root of 100, you get 10. So that's how we got 10 here. That's how we got this 10. That's how we got this 10. The square root of 100 gives us 10. Okay, so that's for magnitude. I think we're done with magnitude, so we hope you're able to do. Okay, calculate the magnitude of this one. 0 square plus 4 square, that's 16. 60, square root of 60, you get 4. Magnitude of this one is 4. This one square is 4. Okay, magnitude of BC. And if you want to find magnitude, remember we said if you want to find magnitude, you write BC. You write BC. To find magnitude, you must put this line. Put this line, okay? BC 2 square plus 5 square plus 5 square, okay, all square root. 2 square plus 5 square, all square root. 2 square is 4, 5 square is 25. Okay, so 25 plus 4, you get 29. So you're going to find the square root of 29. Square root of 29, you get 5 point something. 5.4 approximately to 2 decimal place. 5.4. We get 5.4, right? So that's how to calculate magnitude. That's it. That's how to calculate magnitude. Okay, this one is 2a. They just say 2a. So meaning first of all multiply this one by 2. You get 0.8 and find the magnitude of 0.8. Okay, so 0 square is 0 plus 8 square is 64. 0 plus 64 is 64. Square root of 64 is 8. So the answer of this one will be 8. Okay, so you pause the video like we said. Pause it and solve all of these problems. Now let's go to position vector, which is very important. To position vector means the vector that started from the origin. Any vector you start counting from 0, the 0 origin, is called position vector. So vector A, if I ask you to give me this position vector A, it simply means what we have been doing, but this time around you started from 0. Okay, 1, 2, right? So 2, because it's sliding from here, what it means is that this vector is sliding. Let's use a color to show the vector. Or let's use this vector is sliding from here. Sliding like this. This vector is sliding like this. Okay. Okay. Use a straight line when you doing yours. So it means it covers what? 2 in the x-axis. So I have 2 for the x-axis. Okay. I have 2 on the x-axis. Then for the y-axis we count 1, 2, 3, 4, 5, 6. 6 is going up. We write 6 here. So this position vector is 2, 6. See, position vector OA. For position vector, we say OA because it starts from origin. Because it starts from origin, we always say OA. Position vector OA. So is equal to 2, 6. Position vector OA is equal to what? 2, 6. So position vector, okay. anytime it lags, we lost something. Okay, position vector OA. So it's similar to what we have learned anyway. It's not anything new, but it just means that this vector is start to count from 0. 2, 6. That's it. They ask you to find the magnitude. 2 square you get 4, 6 square you get 36. 36 plus 4 you get 40. Square root of 40. Square root of 40 you get 6 point something. That will be the magnitude of this vector in case they ask. Okay, now here they put some things for exercise for us. They say we should give the position vector of every coordinate point in the geometry. Position vector, give the position vector of A, B, C, D, whatever they give it. So you count each one, you start from here. So for A, I'm going to count 1, 2, 3. So 3 on the x-axis. 6 is going up, is positive 3 on the x-axis. 6 is going up, I'm going to also have 1, 2, 3. So position A is 3, 3. Position A, the vector is column vector is 3, 3, 3, like this. 3, 3, like this for position A. Let's say you want to do for E. For E, if you want to do for position vector E, you got to count from here. 1, you always come back to the origin, the beginning, the origin. 1, 2, 3, 4. So I have 4 on the x-axis. Positive 4 because it's going rightward, and then it's going downward on the y-axis, so I'm going to have a negative 1, 2. This point is for the E, so 2, negative 2. So I put negative 2. Why we put negative? Because it's going downwards, not upward. Okay, so I've shown you A and E, so you can do the rest. Okay, let me show you for H. H lies on the 0 axis, right? On the 0. So x value does not increase, it's 0. S value is what? 0. So this is 0 minus 3. 1, 2, 3. 0 minus 3 for OH, position vector OH. Is that okay? Position vector OH is 0 minus 3. Okay? So this is it. You should be able to show a position vector. A position vector is just a vector that starts from the origin. It's not a big deal. It's a similar thing you've learned. But this time around, you start counting every point on the coordinate geometry, on the vector geometry. You start counting every point from 0. Start to count every point from the 0. Okay? Okay. So we move on. Now we go to vector geometry. We look at them, and then we do the last application, and then we call it a day for this class. Do the last application, call it a day. Now vector geometry, if I have vector A is 3, 2, look at vector A. If it's 3, 2, any vector that is 3, 2 and going the same direction, it will also be vector A, even if it's drawn in another place in the same geometry. Let's say if this is vector A, you can see 3 here, 2 here. This is 3, 2. And it's going like this. Any vector that is going like this, from this bottom left to the up right, any vector that has the same coverage 3, 2 and is going in this direction is A. If it's going down, it's minus A. If it's starting from here and is going down, with shown with the arrow, it becomes minus A. Is that okay? So any vector that has this similitude is called vector A. If it's going like this, is vector A. Any vector, as long as the geometry is 3, 2, even if it's not here, even if you come and draw it here, as long as it's 3 on the horizontal axis and 2 on the vertical axis, is going upward like this, showing in this manner, is going to be called vector A in the geometry. So what this means is that if we come here, if this vector, whatever value this vector is, if you call it A, that's what this vector will be if you're moving from D to C. If you're moving from A to B, it's same as D to C. If you're not going from C to D, it will be negative of whatever A to B was, negative value of whatever it was. So which means vector B, BC, also similarly, vector BC, this one, this vector BC will be same as AD, in geometry. Will be same. Whatever here is what here will be. in vector geometry. And if you say write BD in terms of BE, BD, let's see BD, this one, you say write BD, this vector, this diagonal, write it in terms of BE. Where's our BE? Write BD in terms of BE. Okay, meaning BD is twice BE. Is 2 times BE, right? You can see BE is half of BD. So you say BD is 2 BE. BD is a 2 BE. So we can simply say BD is 2 BE. BD, which is the whole of this one. The whole of this one is twice here to here. It's double of BE. So we say BD is equal to 2 BE. So BD equal to 2 BE. 2 BE. That's it. And remember to always put arrow on top of vector, especially if you're using capital letters like this. Okay? So that's that. And if we ask you AC is twice AE. AC is also twice AE. Okay? And we say CD is same as CD same as AB, right? CD is same as negative AB, right? CD meaning you are going like this from C to D, and AB you are going from this way opposite, so it's negative AB. Is that okay? Move on. So here you have a geometry to identify if this is a vector. See, if vector AG is A, this AG is A. If I'm moving from G to B, I will also call it A because same number. Here will be A, here will be A if I'm moving from D to, but you have to show the arrow to show that you are moving from D to H. But if I'm moving from H to D, it will be minus A because this vector has been described. This vector AE is called small letter b. So if you're moving from here to here, it's also b. It will also be b. But what if we are moving like this? We are moving from F to B, opposite of this one. It will become minus B. To become what? Minus B. To become minus B. Is that okay? And similarly, if we are moving this way, you're moving up against the original direction, it will become minus B as well. This is minus B. But if we want the whole from C all the way to B, it will be minus 2B. If you want the whole of this one from C all the way to B, you say minus 2B. Minus 2B. If you're going up against this, if you're going up like this, it's minus 2B. Is that okay? So these are vector geometry. These are questions for us to, if this is A and this is B, here will also be B. If you're moving from arrow to N, will be B. If you're moving from arrow to Q, will also be equivalent to A. It will also be equivalent to vector A. Okay? But if you're moving from Q to R, to be minus A. To be minus A because you're going in opposite direction. If you're moving from P to M, it's also A. It's also this small letter A. Okay? It's also small letter A. If you're moving here, it's also B. But if you're moving from here to here, it's minus B. Okay? It's minus B. If you're moving downwards, this way, it will be minus A. Minus A. Is that okay? So that's it for that. Let's move on to the next one. So you have a lot of questions to look into. You have a lot of questions to look into for vector geometry. Now the one that is, this is the last one we're doing for today's section. And I think after that, you have a lot of questions which we will post for you to try. Okay, see the student assessment, a lot of questions for you to try. A lot of vector questions we brought up for you to try. Okay, a lot of vector questions. You can try this one after the one we're about to do now. This one. Okay, now let's do the last one for this video, and then you try every other questions that we've enumerated. Okay, now let's take a look at the one I say let's try. Okay, this vector is a t is the midpoint of line PS, look at PS, is the midpoint of line PS. Okay, and R divides the line QS. R divides the line QS. Not equally, but this one is equally. This one is equally. Is that okay? So this is equally, but this one is not equally. It divides the line in the ratio of 1 to 3. So if here is 1, here is 3 times. So the whole length is QS is 4. Consider 4 in a sum of the ratio. Okay, so if I want this out of QR out of QS, it will be 1 over 4. Okay, this PS is A. Okay, they've defined PT, not PS. Okay, you say PT is A. That means from here to here is A. If here is A, here TS will also be A. If I'm moving, because they told us it's halfway, midpoint, because they've used the word midpoint. So if the whole line is 1 or 2, if you move halfway is A, the other halfway will be A. So A plus A will be 2A. So if I want PS, I'll get 2A. If I want PS, PS will give us 2A. Okay? If we want the distance PS. Now, and PQ is B. Look at PQ is B. So this journey from here to here is a B. Okay? Now express each of the following in terms of A and B. They want us to express whatever they want to give us in terms of A and B. Find PS. PS. We've already explained that. PS will be A plus A, which is 2A. So vector PS is A plus A is equals to PT plus TS is equals to PT plus PS. Sorry, PT plus TS. So PT is A, TS is A. So we get this is equal to A plus A plus A, which is 2A. A plus A, which is equal to 2A. So we get that. Okay, it's laggy. We have to wait for 1 minute. So what I'm trying to say, as we're waiting, we just explain. So PT plus TS will give you your entire PS, right? So will be equal to, I think it has restored. It has been restored. Oh my God, we lost everything. PT plus TS. PT plus TS, which is equal to A plus A plus A plus A, which is equal to 2A. So the first one is 2A, that's all. First one is 2A. Now it's a find QS. QS, this one. Okay, to find QS, you can see this vector is 2A and this one is B. They are not going the same direction. So I will say 2A minus B, because we are looking for this one, right? We are looking for this one, QS. Say this, assuming we are looking for QP and they gave us this, you say this plus this will give us this one. But since there is not like what we are looking for QS, it's not like where you stop, that's where you continue. You have PS, so let's write it QS, vector QS, PS, which is the whole of this, is equal to PS, vector PS, is equal to vector PS, slag it a little bit, is equal to vector PS minus vector PQ. minus vector PQ. Minus vector PQ. Now our PS is 2A. Remember, we've done that already. So that gives us 2A minus B. So we get 2A minus B. We get 2A minus B. That's it for QS. That's it for QS. Now, you say find PR. The third one, find PR. Find PR. Vector PR. Okay, now let's take a look at PR. Where's PR? Where's R is here. Okay, so before we can find PR, we must get we already got QS. We must get QR first. To get this one is this. To get PR, we got to say this. Since we are not going like this, we got to say this minus this, okay, in order to get PR. So we got to say, first of all, find QR. QR is 1/4 of whatever you got for QS. So we say QR is equal to 1/4. Why do we say 1/4? 1 out of 4, because the whole QS is 4 segments. So you say 1/4 of whatever we got for QS. What did we get for QS? QS we got 2A minus B, right? QS we got 2A minus B. So we got to write this one, 1/4 of 2A minus B. 2A minus B. So that's what QR is. QR is 1/4 of whatever we got for QS. So that's what we're going to use for QR. Now to find PR, like we said, PR, to find this one, you're going to say, you're moving this way, right? You're going to say this minus this. Because if we are moving R, if we are looking for RP, we would have said this plus this would be equivalent to this, right? We're looking for this. This plus this, will it give us this? Okay, let's try. We say this plus this, right? There will be this. Okay, I think it that way. Now we have PR is equals to PQ plus QR. Remember, our QR is 1/4 of 2A minus B. So our PQ is just B. So we say B plus 1/4 of 2A minus B. Okay, when you get here, what will you do? We simplify this one by saying this 4 is talking to every one of them. So I will write B over 1. Let's change the color. We write B over 1. Write B over 1 plus this one is 2A over 4, same as 2A over 4. This one minus, okay, minus B over 4. You know this is B over 4. So what's the LCM of 1 and 4? LCM will be 4, right? 4 going to this one, 4 divided by 1 we get 4. 4 times B we get 4B. 4B minus 4 divided by 4 you get 1 minus plus 2A. 4B plus 2A. 4 divided by 4 you get 1. When minus 1 times B you get minus B. So we get 4B minus B, that's 3B. So we get 3B, 2A plus 3B. So we get 2A, this one will lead us to 2A plus 3B over 4, over this 4. Or you can say 1 all over 4. It's either you say everything over 4, or you say 1 all over 4, you put it out like this, 1 all over 4. So that's what we get for our PR. Our PR is 1 over 4 2A plus 3B. Okay? 1 over 4 PR, 1 over 4 2A plus 3B. That's what we get for this one, for this PR. The last but not the least is to show that RT is 1 over 4 2A minus 3B. Here's RT here, from here. Okay, let's change the color. We should show that our RT, this one, this RT, we should show that our RT is same as 1 over 4 2A, this way, this direction, RT, okay, this is our direction, is 1 over 4 2A minus 3B. So if we are going this way, let's see the quickest way we can do it. If we want this, we already have this and we have this, right? This one is going this way, this one is going this way. They are not going in the same direction, so we're going to subtract. We're going to say the value of this one minus the value of this one, we get this one, right? Because they are not going in the same direction and they are not ending in the same place. See, this one minus this one, we get this one, we get RT. So which means the value of this one is just what? A, it's just A. So we're going to say A minus, what's the value of this one? We just found this one just now, PRO. PRO we got 1 all over 4, we get for PRO 1 all over 4. I think we got, 1 all over 4. That's where we got this one, right? 1 over 4, 2A plus 3B. So we say this minus 1 all over 4, 1 all over 4 into 2A minus 3B. Minus 3B. We close the bracket. This will be the last one that they say we should show the RT. This will be our RT. This will be our RT. So RT is equal to this RT is equal to what? Is equal to this minus this. Why? Or you say this minus this. This minus this. Or we can say PR minus PA. We could have written that one first, but it doesn't matter. We'll see to the end. Okay? Now, if you factorize this one, this over 1, this over 4, this over 4, right? So if I have A over 1, like we did just now, A over 1 minus 2A over 2A, because 1 times 2 is 2A, 2A over 4. You know, this fraction is talking to everything in the bracket. Minus 3B over 4. Minus 3B over 4. So if you find the LCM, everything will be 4. Okay, everything will be 4 like we did just now. 4 go here, 4 times A we get 4A. 4 times A we get 4A. 4 divide by 1 we get 4. 4 times A we get 4A. Therefore divide by this we get 1. 1 times 2A we get 2A. Right? We're going to get 2A. So we say 2A. 4 divided by 4, 1. 1 times 3B, we get 3B, negative 3B. We get negative 3B. Now, 2A minus, 4A minus 2A, you're going to get what? You're going to get 2A. 4A minus 2A, you get 2A. And then minus 3B. You cannot subtract, you write it minus 3B. Then the denominator, you just write it. Either you say over 4 or you say over 1 all over 4. Either you just say everything over 4 like this, or you put you make it a fraction like 1 all over 4. The denominator will be 4, numerator is 1 always. So that's what our RT is. That's what our RT is. Now we go to see what they say we should show whether we got it. Okay. Yeah, they say we should show that it's 1 over 4, 2A minus 3B. That's exactly what we got. That's exactly what we got. So with this, we come to the end of our today's class. What you should do as a good student is to pause the video, go through what I have done here, and then come and solve all of this. This is the type that will be in the Igcse exam. Okay, if you're looking for this type of question, this one, and probably maybe few ones we've talked about like magnitude and the likes, but the major ones in the exams are these ones, the major ones. I'm not saying the others will not come. So you should be able to use it to solve questions like this. And you have student assessment to practice from. We put a lot of questions for you. Pause the video and go through like this one. You know, something like this. Try this one and see. They also give you something to show that ST is 1 over 20 or whatever. Okay, so you can see like this one is very similar to what we solved just now. So try, pause the video, try and solve all these questions, try and solve all of them, practice all of them. Okay, so with this we come to the end of our today's class. Thank you for joining us.